Thanks for coming. I'm not going to keep you for long. It's the last talk today. I'm sure you all write unit tests, and you definitely use JUnit or maybe test-ng, which is quite the same. I will try to suggest something new in this quite old area, and let's see what you're going to think about it. The unit testing is in general very important, that unit tests must be maintainable, must be readable, must be clean and easy to understand, because if they're not readable, if they become a mess, then we just throw them away. It's really difficult to maintain a unit test if it's not written properly. That's a really very common problem, and people are trying to solve that problem for many years. For example, that's quite famous definition of how unit tests must look. They have to be fast, they have to be isolated. Well, fast meaning that they shouldn't run for each particular unit test. Test method should not wait for too long. They have to be isolated, so they must not depend on each other. They have to be repeatable, meaning that if it fails, it's going to fail every time, so it must not be randomly failing. It has to be self-validating. I don't know what it is. They have to be thorough and timely. There's so many definitions. I don't really want to explain all of them because there's so many sources and definitions of how they must look. This is a list of books which I found about unit testing. You may want to read them. I read the first one, which defined the idea of unit testing announced the term TDD, test-driven development. And I think I checked one more. I don't remember which one, but you definitely can take a look. So my point is that there's so much information about unit testing, and people are trying to tell us how to make them better. I'll try to tell you the same, but I'll give you one extra recipe. I found on the internet some unit testing antipatterns. So what we should not do in order to keep our tests understandable and make them good and keep them good. Again, I don't know what these words mean. If you pick one of them and say, what does it mean? I'll not be able to answer. Maybe some of them I know, like logic in tests I can understand. I can understand maybe the giant. All the rest is, if you Google for them, you will find the definition. It's not going to be difficult, so try it out. And here's the link, so you can... well, this one I know as well. This one means that you have some code, and then instead of looking at the code from the front face, you just go deep and deep inside that code and test what really happens inside. You shouldn't do that. You should take a look at the code as a black box and just probe it on the surface. So don't do deep probe. That's what it is about. And probably this is just really like 20% of what people invented and called these anti-patterns. There are many of them, and you can start from that link. I'm suggesting something else. I believe that there is one pattern which is missing, and we're going to talk about object-oriented programming. That's what I'm always talking about. And if we're talking about object-oriented programming, then I think that we are missing one anti-pattern, one bad thing which happens in tests is the algorithm. So we should not have an algorithm inside a unit test method. That's my point. It's quite controversial. I'll show you what I mean. And here's the footnote that provided we're talking about OOP. So if we're talking about something else, some procedural programming or functional programming, maybe this whole story is wrong, is definitely wrong or different. So usually the JUnit or any other unit test is basically a procedure which is wrong. It looks quite often like that. Let's say we have a code, we have a book, and then we set the language of the book, we set the encoding of the book, then we set the title of the book, and then I take out the URL of the book, and I assert that the URL contains that particular characters. This is a very typical unit test which tests some class, which is supposed to probably encode the URL inside. We have the algorithm here. So first goes the algorithm which does something, manipulates somehow with an object, constructs it maybe, or gives some instructions to the object, and prepares the object for the next step. The next step is we take something out of the object, we generate some output. And then, step number 3, we do the assertion. This is not a bad unit test. I've seen worse unit tests which have like a number of asserts. They have some algorithm, then assert, then another algorithm, another assert, again some code, again some assert. So it could be a complete mess. So this unit test even actually looks more or less okay, but I think that the existence of the algorithm is what makes the test more, bad instead of being good. So I'm suggesting, this is the claim, which I wrote a blog post about it just really a month ago, maybe even less. And here's my suggestion, is that a test method must have nothing but a single statement assert that. So the entire body of the test method must have just one assert that. And everything has to be inside that statement, inside that call for this method function, whatever. Again, provided we're talking about Java. So all this example will be about Java. So here's how that test we've seen before must look if we refactor it. So instead of having the algorithm first and then assert in the bottom, we have just one assert, and then inside the assert we have a book, we build it somehow, and then we have this matcher which says how that book must look like. And then the assert that compares them. Who knows what assert that is? Who's using that in your tests? Almost everybody. It's coming, who's not using that, I'll explain a few slides more later. I'll explain what it's coming from. So nothing should go in here. So nothing should happen before the assert that. That's my suggestion. Do you think it's reasonable? So far, no. Who doesn't like it up so far? Okay, like half of you, more. That's great. Again, it's experimental, quite experimental. I'll show you in the end how it worked for me, and I applied it to my library like actually 5 days ago, and it really helped me to write a better code. So maybe it will help you too. The question is what this assert that means. It's quite frequently people ask me like, how can you read that code? And why this, what this text has URL or string contains mean? Because we are supposed to name our objects as nouns like book, table, story, whatever, file. But now we have has URL, string contains. So what kind of objects are they? And to explain that, I just made that the text which explains that line in Java. I converted it to the real to the plain English. So on top we have assert that book has URL and then string contains, but in English it says, we assert, well, I forgot to put the we, so let's say we assert that the book is similar, the book, the first line, is similar, and then goes the second line, to a book that has a URL that contains a string that is equal to that text. Because we don't want to have this a book that has a URL, and then a string that is equal to, or a URL that contains a string. That's why we made it shorter. That's why we compressed the name from a book that has a URL, we just have has URL. So in reality, that name of this object has to be a book that has a URL. And that will be a perfect name for an object. Like we have a book, we have a table, and we have a book that has a URL. So we actually build an object we want to test, and then we build an object against which we want to test our object. And then we compare them. So we build something which is supposed to be a perfect book for us, which behaves the way we want, and then we build another object, a test object. I don't know what's the good name for it. And then we have two objects, and then we just compare them. And if they match, then the test passes. If they don't match, then we fail. So the first object is our real object, which is book, with the title and everything, and encoding. And then the second object is an object which can be similar to the one we have in mind, to the one we're testing. There's a library. Who's using this library? Oh, that's great. So Hamcrest is who knows what the name means? You see? So actually, I was wondering last year what this name is coming from. So this is actually matchers, but all the letters are changed their places. So this is matchers, but different the letters are misplaced. That's what the name is from. So actually Hamcrest is matchers. So it's just a library of matchers. I believe it was introduced by the authors of this book. I tried to Google who is the real author of the library. I think these guys are actually originally created. It exists for a number of languages. Java is the main one. It exists for PHP. It exists for, I think, C# as well. So this is the library which provides these objects which we can combine into one another and create the object that this test thing. So which helps us to create this has URL and string contains. So string contains is coming from matchers, or from Hamcrest, sorry. So string contains is an object from the library Hamcrest. Has URL I created myself. Well, for this example. So Hamcrest is a good library of quite simple. There are probably like a few dozens or maybe like 100 objects there, which you can combine one into another, which you can combine and build a bigger one, and then that bigger one will be comparable with your object which you're testing. And then when you compare them together, the Hamcrest will generate a message for you, what's wrong and what's right. Like, do they really match or they don't match? So if we remove the code before and we just leave assert that and we just have two objects and they compare it to each other, then I believe that the majority of anti-patterns will just disappear. So they will just not happen. Well, for example, the anal probe will go away, the one you mentioned. Because you won't be able to do anything inside an object, because all you can do is that you can create an object and then compare it with another one. So there is no anal to probe, actually. That's the whole thing is just an object which can only interact with you through the surface. You cannot penetrate it anyhow. And the giant will go away, because you cannot create a giant unit test while you just have one assert. So you just have one place where you can compare two objects, that's all you can do. So there's no place for the algorithm. So technically, the test will become shorter, because you just compare two objects. The freeride, who knows what freeride means in the unit test? It's an anti-pattern, which means that here's my unit test method, and I just jump in and say, hey, how about I inject something here, 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 and there, like put something more, and boom, it tests something more. They call it freeride. So I just don't look at what's around me. I just want extra assert, I put it in. I want extra verification, I put it in. I make it bigger without paying attention to what's outside. Logic in tests. So they're complaining about too complex logic. Well, it's not about too complex. It's about assuming about the logic inside our objects, something like that. So many of them will disappear if we remove the algorithm. No algorithm, no problems. Obvious benefits for me. Now I'm getting to the most important points. So I found like 5 critical, not 4. The last one is just better design, just more object-oriented. So 4 things which are really technically improving the test. First of all, reduced complexity. So the complexity will be reduced. The test will not be as complex as it was before. Immutable objects. Objects will be inevitably immutable, because you will not have any setters. You will not be able to modify them. I'll explain later. We'll have shared matchers, and we're going to have fake objects. So let's start with the first one, reduced complexity. Here's the test. First of all, there is no freeride, meaning that we cannot inject easily anything in here. So I cannot put any extra code and verification and validation and any extra asserts in there. So definitely there will be no freeride. So nobody will be able to modify my test easily without breaking the logic. So every next test will mean a new test method. You will always have to create new test method. The second one, there will be no multi-asserts, which is also an anti-pattern. So when you have multi-asserts, assert that, assert that, assert that, it's wrong, because when the test fails, you don't really know what is the problem. So which one of them fails, you need to jump in, you need to understand what actually happened there, why my first assert works and the second one doesn't. So is it the whole test is wrong? Do I need to throw away the entire test? Do I need to rewrite it? That's a typical problem. In this case, there will be no multi-asserts. There's only one assert. And there will be no before and after, which is also considered by many programmers is a really bad thing to have. Who is using before and after in your unit test? You see? This is in general an anti-pattern. You shouldn't. So your test method has to be like Uncle Bob said, they have to be isolated. So they have to be independent. They shouldn't depend on each other. But when you have the before here and after there, it means that all of them depend on one thing. This is just against the idea of isolation of unit testing. So it shouldn't be like that. Your unit test has to have everything inside what's needed. If you want to get rid of the duplication of the code, then you move it somewhere else, but you don't put stuff on top and then below. So this before and after is just a wrong design in JUnit. It was just wrongly designed. So try to avoid it. In this case, you will just not have it because you cannot put it anywhere. You're always going to have new objects every time you need it. So the complexity will be lower. Unit tests will be simpler. The second one, immutable objects. All your objects will be immutable because it's not possible to have a mutable one. You cannot have setters because all you can do is you can call constructors in this case. I'm not calling any methods here. I'm just saying new book. There's no dot something. There's not dot set, dot get, whatever. I'm just building an object. I'm just constructing it. So your object will be immutable. So it will just work. I mean, you'll not be able to use any setters. There will be no temporal coupling. Temporal coupling, who knows what temporal coupling is? Okay, probably you checked my book or something. So temporal coupling is the dependency between a number of lines. So when you have two lines and, for example, you say book.init and then book.print. So there is temporal coupling between these two lines. So you cannot do book print and then book init, because logically it's wrong. So first of all, we need to initialize the book and then we can print the book. But the compiler doesn't know about that. For the compiler, these two lines, they're absolutely equal. So there is some dependency between them. They definitely have to go one after another. But if you replace them, if you swap them, the compiler will not understand that. The code will compile and the test will break. But you will not be understanding what's going on, and it will be difficult for you to realize that these two lines actually have to go one after another. When it's init and in print, it's easy. When there will be something more complex, it will be more complex, difficult. If there are like 50 lines, and these 50 lines depend on each other, and temporal coupling means temporal from the world, it's coming from the time. So it's temporal, meaning it depends in time. First of all, it's initialized, then it prints. So you will lose that information, and the test will be fragile. You will be easy breakable. And of course, there will be no procedures, so all code will be object-oriented and declarative. So I just declare the method. I just declare an object. I'm not manipulating an object as in procedures. I'm just declaring them. The number 3 advantage is shared matchers. So this is really important and really a huge benefit, very beneficial for us. So that has URL is a matcher, well, by the definition of the library. And we can use that matcher in many places. We can use it in one test, we can use it in another test, we can use it in many places, so we can share the testing code, the code used for testing, in many test methods, in many libraries. We can even ship that code together with our productions code. So when I'm developing libraries sometimes, then I sometimes provide that matchers for programmers for the future, so they can use them in their code. So together with my production, together with the book, I can ship the has URL. So I give you the book, the class book, you can use it, and also I give you the has URL, which you can use in your tests. So that's the piece of code which I can share, that matchers. And of course, we can share them between test methods, test classes, and use them everywhere. This is a big achievement. Usually people solve the problem of code duplication by some private static methods. It's quite popular. In the test class, you create some static stuff, private static stuff in the bottom, and then you put some code in there which you want to be used by some of your methods and some of them. This is solvable by that stuff. So you don't need to do that. You don't put any static below, you don't use any private static. You just create classes which help you to do this matching, which help you to... Who has an experience of writing matchers for Hamcrest? Oh, that's great. So you know what I'm talking about. That's what it's not really all so easy because I don't think their design is so elegant. I think they try to solve many Java problems while doing that because they made that matchers suitable for different situations. So writing these matchers is not an easy task. If you really want them to make like verbose and properly printable and properly reportable. So they need to report the problem when the problem happens. They have to report it correctly. But if you know how to do it, you will have fun, and that matchers will be shareable. No code duplication and cleaner logs. So these guys are reporting to the log way better way than if you just compare two numbers and say, hey, the test just fails. In this case, the test will fail with the message. I'm expecting the book with that title. Well, I'm expecting the book that contains that text inside the URL. But the real book is coming in this one. So it's going to be a properly formatted text, which says exactly what I just said. I was expecting the book with that title inside, with that text inside the title. But the real book is semicolon, and then it's going to be the book dot toString. And then you will be able to compare and see what's actually going on. So the logs will be cleaner. And the last one, no mocking. Do you know what mocking is, right? Definitely. And do you know this is really bad to use mocking? You don't know that. Who knows that? Some of you. So mocking is a really terrible practice in general. Read the internet, it's not me saying. So it's just very popular very popular articles about that, even maybe books, which explain what's wrong with mocking. So mocking has to be the last resort. So you can use mocking, but only if you have no other instruments, if you just have no other chance to do something better. So mocking in general, I'll give a few words. I wasn't going to explain why mocking is bad, but in a few words, mocking is when inside the test method, before you can do something, you need to prepare some objects. For example, the book is expecting, let's say here the book encapsulates only the title, the string, and the locale. But let's say the book encapsulates the database. A database. Because the book wants to go to the database and get the title from there. So in order to test the book, we need to provide the database in there. We don't want to call the real database inside the test. We want to mock the database. So we create like an object which is not a real object. We just create something which looks like an object. Who knows what mocking means in English? The word mocking. Who can say it? Кривлять. Yeah, so it's like making fun. So this is the real database, and this is the database which is mocking the real database. So it's like pretending to be the real database, but it's not the real database. So we create this mock, and then we give that mock to the book. But the problem is that when we create the database, when we create that mock, we are making assumptions about how that database will work and how it works inside. And how, not inside, we are making assumptions about how the book will use the database. So we kind of assume that inside the book will call method connect to the database. We don't know what actually happens inside the book because we're testing the book on the surface. We shouldn't we shouldn't look inside the book. We're just saying we shouldn't in a good test. But we don't have this ability. We need to create a mock, and then we have to say in the test that, look, we understand that the book will definitely call the method connect. So that's why the mock database, that object, has to respond to the connect method. But this assumption makes our test will cause many false positives. Because if in the future the logic inside the book will be changed and the connect method will not be called and there will be some other method called, for example, connect immediately or connect quietly. But we mocked only the connect. So our test is designed to work with the class book, which calls method connect. Tomorrow we refactor the class book and we change it, and now it calls connect quietly. The test breaks. The test breaks, but the code works. So the test is supposed to break only when actually the code breaks. If the test says, boom, it's a red flag, the code doesn't work, it means for me that I have to go to the code and actually fix something. I broke something. But if the test fails and the code still is correct, it's called a false positive signal. So it raises the red flag while the situation is not red. That will happen if you use mocking. So if you have so many mocking, you know that situation when you have so many tests and then you start to refactor the code and some of them just fail. You go in there, you see like 100 lines of code, mocking. And you don't know what to do because it's so complex, it's so complicated. You just throw away the whole test. So you cannot use the test properly. You cannot use it as a safety net, so-called. You just throw it away. So it's not going to happen if you do it like that because there will be no mocking. You will be using fake classes or That's what I call them. So you will be using classes which are designed for testing. So they will be like fake database or fake connection or fake something. The classes which are provided by the libraries, and you can just use them inside your test method. And now more practical. So I'm finishing the theory, and I'll show you two practical examples. So we have an object, a matcher. So basically now our test has three things. We have an object, we have a matcher, and we have assertion, just like I said. So two things. The first, you build an object, then you build a matcher, then you compare, and it works or it doesn't work. I think it's a better design. Now two practical examples, and we're done. Example number one, I took it from OpenJDK, the test called random stream test, created some time ago. This is the code from OpenJDK. It's not my code. This is a real unit test from OpenJDK. What it does, it is testing the class random. You know what random is. First of all, it makes a seed. Then it creates the first random class, R1. Then it has an array of numbers. Then it puts numbers into the array, random numbers. Then it creates another random, another instance of class random, which is called R2. And it fills the array using a different method, a method which is called ints. So first it was next int, now it's ints. See the difference, right? So they're trying to test that the class random with exactly the same seed will generate exactly the same random numbers using different methods. So next int will generate, let's say, I don't know, sizes like 10 or 100. So we'll generate 100 numbers, and then calling ints with the limit of 100 will generate exactly the same. So assert equals will compare two arrays, and they have to be equal. Pretty straightforward. What do we have here? We have an algorithm and assertion in the end. That's what I said. So this is wrong. This is what I don't like. It's quite procedural. So this is just a procedure of, it's not object-oriented programming, in my point. How would I fix that? I would do it this way. This is the test on the left. First, I generate the seed, like it was before. And then the only thing, all I have is assert equals. Well, I'm not using assert that, but assert equals to make it simple. And then I have two parts. The first one is one object, and the second one is another object. So I'm comparing two objects, two arrays actually. The first array and the second array. The first array is generated, I cannot generate it through a procedure because I don't have the freedom to put any code on top of assert that. That's why I move the code aside and I create another class which is called array from random. So that code, so I kind of took a part of the procedure out and I created, in this case it's not really a matcher, it's quite simplified example, but the point is that I moved part of the code, part of the algorithm outside and into the class, and then that class generates me an array. And here I just compare one array to another array. I think this code is better for many reasons. Again, first of all, it's easier to read, well, for me at least. And second, that piece of code is shareable, so I can share it with, I can use it somewhere else. I can use it in another test. I can use it, I can reuse it. I can test it as well by itself. So I broke down, I reduced the complexity. The complexity of this text is lower. And I have two parts, so it's more effective. And the second example, which happened 5 days ago. This is the library I created. I started to create actually 5 days ago. And it's a simple library for Java with Java primitives, Java object-oriented primitives for input, output, for text processing, for collections, manipulations. So I had a problem of how to copy a file, let's say, how to copy something from something. So we have an input and we have an output. In this library we have an interface called input and we have an interface called output. So I want to design something else which will allow me to copy, to put some text into the file, for example, or copy one file to another file. So I have two entities, two things. One of them is input, one of them is output, and I want to copy input into the output. So the first approach was this, like let's design a pipe. A pipe is like a tube, a pipe which you first create, and then you encapsulate an input, then you encapsulate an output, and you call push, and in this push will have some kind of a loop which will read and write, read and write, read and write. And somehow this content will be copied. As input I have just the text, as output I have file as output into the file. This design is clear so far. Then I started to create a test for this code, for the pipe. So I want to check how this pipe works. And this was my test. First, I decided to copy a text, not into a file, but into the output stream. So I create an output stream first, a byte array output stream. Then I create a pipe which encapsulates an input, simple text input. Then the second parameter is I encapsulate output stream as output. It's also a class from the library. And then I call push. And then I have an assert to check that what I have in the array, in the byte array, actually contains the hello. So something was copied there. So again, you can see here I have an algorithm and then I have an assertion. It worked fine for just 2 days, and then I realized that I will be in the conference and I'll be like, maybe it's a good, I realized that how about I apply that rule which I want to promote. How about I apply that rule to my own tests? And I looked at that test, and my question is, how can I remove the algorithm? How can I make it different? How can I improve that code and make it, not improve, but at least remove the algorithm? And I actually refactored the pipe. So because I needed to get rid of the algorithm, it was necessary for me to refactor the pipe, because I cannot implement the algorithm in an object-oriented way where there's only assert that and 2 objects if I have the procedural pipe. Because the pipe is actually a procedure now. You build it and then you push into something. You call push. So it doesn't return anything. It just does something inside, which is quite procedural approach. To make it more object-oriented, I did a refactoring. Now I don't have a pipe anymore. I'm not sure you follow, but just watch it. I'll say it anyway. So instead of a pipe, now I have an input which encapsulates another input and an output. And the moment I read from the input, it gives me everything what's in the input and copies everything, all of that, into the output. We have a similar stuff in Apache Commons I/O library. It's called T input stream. So that's why the name T. So it's actually you have the source of data which is coming from here, and then you wrap it into another T input stream. And now when you pull the information out of here, it gives you everything, but it also copies everything into the output stream. Who has an experience of using T input stream from Apache? There you go. So you know what I'm talking about. Well, I'm using it quite sometimes. In this case, it's exactly the same design. So we have T input. Every time I read from that T input, it will give me the hello world, but also going to save everything into the test file. That's how I refactored the pipe. Now it's not a pipe anymore. It is more object-oriented stuff. It's a thing. It's an input. It's still an input. And now I click input.read. It will return me the H letter here, and the H letter will go to the file at the same time. So now, when I call length of inputs, and if I want to calculate, it's also my class. If I want to calculate, the moment I want to calculate the length of the input, it will do the full cycle. It will read the whole content. It will read hello world. And as a side effect, the entire content will go to the file. That's way more object-oriented, in my opinion. And I made a refactoring. This is the GiftHash, which you can look at the library and see how I actually refactored the pipe into that design. And then the test became like that. We have no algorithm. We have an object on top, and then I assert that that object contains hello. So because I wanted to get rid of the algorithm in the unit test, I had to refactor to change the design of my production code and make it more object-oriented. So maybe it's a good thing not to have an algorithm inside unit test methods. Well, it has just one line, actually. Before the assert that, there's one line which is not an algorithm, but it's a declaration of a variable. We cannot technically get rid of that in Java because in Java we can't. But if Java would have well, actually in Java we can do like that. This is all I can do. So I can remove the, it's not an elegant code now, but I remove the actual, you see the actual assignment of the byte array here, I can put it here. And that in that case I can say, okay, it's clear, it's even better, there's no algorithm. But even better would be like that. If I remove the declaration, then Java would have the feature of this SBAOS. So instead of declaring all the variables, I can declare them as the way I go. So I need it here, I put just a value, and I put like a label there, and then I can use the label later. So that's it. That's the link to the article on the blog. That's what I wanted to present. Maybe you have questions. Yeah. But keep in mind, it's very experimental, so I'm just suggesting an idea.
Okay, so I have, of course, so many questions, but I will choose one. And probably you know that in tests we can verify state and verify behavior. And all your examples that we just saw, they verify state of the object. How can we verify behavior with such approach?
Yeah, it's a good question. I think in general, I think actually we are here verifying behavior and we cannot verify state. So I was expecting you to say quite the opposite. Because here I'm verifying how this
verifying the state of the output stream. But for example, behavior can be write to file, just like on the previous slide. And how can you verify that actually file was created with expected data in it? With such approach.
So you're saying how we can verify the side effect of that. So when the behavior is that I'm like, let's say your behavior
means that you need to verify that some certain actions were performed. For example, write to file were actually performed.
You're talking about side effect, not behavior. Because behavior is like, it's like I'm saying, like, can you give me the $? And you're saying, no, this is the behavior.
Side effect is just one example of behavior. Behavior may be calling the method from another object.
Behavior is what the object exposed to me as a client. So if I'm asking you, can you give me the money? You're saying, no, this is your behavior. But if I'm just looking at your pocket, this is your state. So do you really have the money? Okay, yes, you got the money. This is your state. And but if I'm saying you give me the money, you're saying no, but at the same time you put the money somewhere in the drawer. This is side effect. So if I go to the drawer and say, okay, did he actually put the money there? Yes, that's side effect.
And in all the tests that you demonstrated, you check that you actually checked my pocket in all these examples. How can you check that I throw money away while you...
While I'm asking. Yeah. While I'm asking. Well, if in that case you're talking about the side effect. I'm doing it here like that. So look, my side effect is byte array stream. So when I'm reading, you see I'm creating the input, T input. The T input encapsulates the hello world, which is the source of data. Then there's the destination of the data. And then I'm saying, what's the
You check the state of the byte array output stream in the end.
Input stream as text is equal to, well, yeah, this input stream as text converts the input into text again. So it actually reads everything. So when I'm calling this one, is equal to, we'll definitely call from the input as text, we'll call the toString. So give me the content. And when the request will be made, the entire copy operation will happen.
But you're verifying the state of the byte array output stream here. Don't you agree?
The state of the byte array output stream.
The state of the object, yes.
Of output object, of byte array output stream.
You don't verify what actions were done. You verify the state of the object. And my question is how to verify actions that were
But
performed.
actions, yeah, I think I understand the question. But the actions, they happen here in these matchers. So matchers are doing the actions. I'm building an object, there's no actions, I agree. Okay, I'm building an object, there's no actions, no method calls. And then I give this whole object to my matchers, and then matchers are trying to do something with an object. So the actual operations, the actual method calls will happen in here, in the matchers. That's what's happening. I think this answers the question. No? And if you want more operations, you create more matchers, more complex matchers. Well, matchers which will do the stuff you want.
Okay, let's go to concrete example. I will take 1 more minute, and if no, we will skip the question. So if you return the file output stream in this example of the test, just like on previous slide, how will you check that content was actually written to the file system?
Well, like the same I'm doing with the byte array output stream. I'm checking the content.
You're checking byte array output stream here, or you check your T input. But how will you test your file output stream? You need to write test for a file output stream class as well.
Well, I have the test for file output stream. We have file output stream there, and we have a test for it. You can check the library, and I can try to show it a bit later when we finish. I'll show you the code.
Okay.
We have a test for it. And also, it doesn't have any algorithms. It's a good question, but I'll check it out later to convince you and myself.
Hi, Igor.
Yeah.
I have one question. How you could check interaction of objects? For example, we have one object and the next one. How you can check that they interact? One call another, maybe.
I think we need, well, they interact inside some other object. So they don't interact just because they exist together. Like in this case, we have, for example, input, we have output. So they interact inside something else. So we create that something else, and then we see how this something else behaves. So the question is always where they interact. You have some production code, so what do they do there? How they interact.
If it's API, for example, and we need to check that when we call API, something else was called. How we can check it?
When you call the API, you want to see what happened inside.
Yeah, pretty simple example.
But again, we're talking about the side effect. Maybe we shouldn't do that. So if you call the API, you get something on the output, check the output. So why do we need to see what happened inside?
But not every time we have output. Not every time we have results. Sometimes we just need to check, okay, this service was called and we have some results.
Like just like delete it from the database, yeah? And the result is okay. And we need to check actually that was deleted.
Actually, I just don't care what was called, but I just need to know that it was called.
And when the okay comes back, it's not enough for you.
Yeah, it's not.
So
enough.
you don't trust this okay, you need to really be sure that something happened there. Yeah, that's the problem.
Actually, I like the previous question because I haven't seen any examples how we can check behavior. I saw some samples when we compare two objects. Okay, we just check state. It's normal. But when I want to check that something was called or something happened, how I can do this with this approach?
I think you always need to convert what you have into some kind of an object somehow. Yeah. So your situation in the database must be represented by an object somehow.
It's why I'd like to see more examples.
Yeah, me too, but I don't I don't have many of them right now. But I'm writing the article, I'm writing the library right now, and we are writing the article right now. So we'll have more examples. Maybe for sure I'll be able to show them more and more. But the idea is that you will have more and more code in the matchers. That's my point. So you will move the code into matchers. That matchers will know what to do with the objects. And then in the test, you will just build some object and give it to the matcher. Or matchers, and then you will combine a big matcher which will test what's going on, and then you compare your real situation with your expected situation.
I understand and I get the idea of matchers and how we can use them, but I still cannot understand how we can check behavior. So for me it's a question. Okay, thank you.
Yeah, it's a good question, yeah, but I still don't understand why you guys are calling this behavior, and I think you state this behavior as like you're swapping these two concepts, state and behavior. State is encapsulated. You never check that. You never touch this. Yeah, probably, yeah. But I think the state is always encapsulated. You never touch it. It's like in attributes. They're always private. And behavior is what the object exposes. So you don't check the state of an object anyhow. You just don't know it. It's encapsulated. It's hidden, always. I think so. Well, I'm sure. Yeah.
Okay. Thank you for the great talk. I have a question. So I know that there is another paradigm how to write unit tests, which is called a given, when, then. So we have three stages. Sometimes they can be quite elegant, reduced into one statement, into one assert. And also some of your examples also demonstrated this thing. But for example, as the code example which is presented on this slide, you know, it makes me, how to say, it requires from me some mental resources to understand, and even more mental resources to write such code, such nested things. So it might look like this anal probe, but in terms of nested braces and so on. So it looks complicated for me. So, and what are benefits of your approach comparing to given, when, then? Thank you.
Yeah, this given, when, then is called behavior-driven development, BDD, if I'm not wrong. So you're saying that this one is, this nesting of objects is more complicated than just a flat algorithm which does something and then validates, something like that. Well, like I said before, I think these are the advantages which are, so first of all, reduce complexity, because when we have this nested thing, it's always one thing. So you cannot easily break it, you cannot easily inject something in there. It's something which stays solid all the time. So for me to, well, if we have this nested structure, it's always one structure. I cannot extend it easily by just injecting some extra line here and saying, hey, fix like one extra setter and now the test works. It's always the whole thing together. So I need to really refactor it if I want to change it. So the complexity is less because it's always one thing. So I don't need to process the information of what's going on. I don't need to think procedurally. I don't need to think like a computer, like how this test executes line by line. I just look at it and I see that it compares that piece with that piece. I don't know what's inside that piece, I go in deeper. I shift my mind one level right. And then I go in there and see, okay, this whole thing works? No, it doesn't work. How about we test a smaller thing? So I take that smaller thing, move it to another test, and now I test a smaller thing. It doesn't work, I take smaller. So I can go level, deeper and deeper. When the test is flat, when the whole code is flat, I mean, no indentation, then I don't know how to decompose it to smaller problems. In this case, smaller problems are easily taken out. You can just shift your mind right and then take it out and test it if it doesn't work. For example, I have this test, and I run it, and it fails, it breaks here. So the whole thing breaks. I don't want to test the whole thing altogether. I need to make sure maybe text as input doesn't work. So I just take test as input and move it to another test and test it there. It works, okay, let me test this one, new output stream as output. Maybe it doesn't work. Then I test it somewhere else. Okay, they both work, I have tests for it, great. Now let me check T input, does it work? I also test it somewhere. And then I go higher and higher and then the whole thing works together. So it's always easier for me to decompose the bigger problem. So the complexity is the number one thing, well, for me. Immutable objects. So all objects will be immutable. There will be definitely no setters. You have no ability to have setters because there's no algorithm, so you cannot initialize an object. You can only initialize it through the constructor. Why immutable objects are better? That's a separate discussion, but some of you may understand that they are definitely better. Shared matchers. You will put a lot of code into matchers, so your tests will be smaller, your tests will be light, and your matchers will be quite powerful. And they are shareable. They can be used. They are reusable. You can use them somewhere else. So it's also a great benefit that you have shared matchers. Test methods, they cannot be shared, but matchers, they can. And if you have no ability, if you prohibit yourself, if you say no to algorithms, there will be no algorithms, that means that you will create matchers. And that means you will get an ability to reuse them. That will be a big achievement. Because now not so many people use that matchers. We just use them sometimes, taking them from Hamcrest, sometimes maybe writing our own matchers, but only when they have no other chance to do the code properly. And of course, we're going to have no mocking. We'll just have fake objects, which is also a big achievement. So I think, and in general, it's a better design, more object-oriented. That's my take on that. One more, maybe two more, and we're done.
A rather simple question. This has URL matcher is designed by you, or this Hamcrest can help you with building it?
No, in this case it's mine. This has URL, it's mine, because they don't have that. Because has URL need to understand what the book is. So the book comes in here. So the Hamcrest library, this assert that, will get the book and pass it as a parameter to has URL. So the has URL is something which knows what to do with the book. So the book comes in and has URL says, okay, how about I check the URL? And the has URL will call get URL. And that's going to be the behavior, what we're talking about. That's going to be the behavior of the book. So the behavior will be tested by has URL. So the has URL will test how the book behaves. And then it will call the string contains. The string contains will get the title there. It will get the URL. So the has URL will take the URL from the book and pass it here. That's what it's going to do. So the string contains will receive the URL.
Okay, and if you design this has URL, if we think about another option like just dot get URL and
remove the matcher.
Yeah. What advantages you see in your object?
So you're saying we can do it like this, actually. Like this.
Get URL.
Book get URL dot contains, right?
And book is new book.
Yeah, and book is new book. Well, yeah, it's okay. It's going to be as well not a big problem. It's okay, but it's not going to be shareable. So this get URL, for example, we take the URL and we don't want it to be null, for example, always. So it has to be something. In this case, we will get the null pointer exception when you call dot contains, right? But the has URL will do it properly. The has URL can check, will have the checker inside and will check for the null and will raise a proper exception. And then everywhere where you're going to be has URL, you will use it everywhere. Then every time you will check for null properly. So this one is not shareable. This code is like hard-coded inside the test method. It stays there forever. When we have has URL, it's a different story because now we have a class which can be reused in many other places. That's the benefit. One last question and we're done. And about the book, somebody asked me about the book while we're looking for the microphone. So here's the email. You can email me and you will get the book. We will ship you the book and the price will be 50% less for all the members of the conference. Just send the photocopy of your badge.
Thank you for email. When you make some, thank you for a great report, sorry. When you make some testing, you have several options. One of them don't use in mocks. And one of them is using mocks. In a case when you don't use mocks, your test became some like integration tests. And
yes.
It's really hard for your performance. Do you have some performance problem when you make some really huge objects or huge operations which interact with a lot of part of system when you're using this concept of no mocking?
Yeah, it's a good question. So I'll repeat the question as how I understand it. So mocking is bad. We've already agreed about it because mocking makes us, forces us to make assumptions about how our objects behave, how our objects is using the database. So when the book is using the database, when we're mocking the database, we assume how the book will interact with the database. Another approach is to do the integration test. It's quite the opposite extreme. The integration test is actually start the MySQL database or connect to the real MySQL database and then let the book work with the real database. So no mocking, nothing, just here's your connection to the real database. Not production database, but some people have like database for testing, some people start the database, some people have it inside their Docker container. It depends. So it's called integration test, when the full thing, the big external dependency is there, and then we let the book talk to the real dependency. That's another extreme. This is slow, the mocking is extremely fast. This one is it's the best way to test, because in that case you're really gonna let the book connect and run the SQL query, everything. So it's the full integration cycle. It's perfect. This one is not perfect at all, but it's really fast. So you need to find something in between, because otherwise your test will be really slow. You're right. Not really slow. It depends on the application. If it's just a small MySQL database or Postgres database which you start inside the Docker container, well, it's extra a few seconds to start the database, and then your tests will be, okay, a little bit slower. It's not going to be super slow, but a little bit slower. So if you can use that way, do it that way. If you don't want to do it, you can do, that's what I'm doing in most cases. You can do, sometimes it's not possible. Sometimes it's not possible. For example, I have applications which work against some API, like GitHub API. or some Slack API. So I cannot start a fake Slack server inside Docker container. It's just I have to connect to the real Slack server. And I can't do that on my tests because I can't. So I need to create a fake server, a fake implementation of Slack or of GitHub or something, some API. And that is what I call fake objects or fake API, something like that. So you spend some time on designing the code which will behave like a real Slack server. Of course, it's not going to behave like a real machine, like a real API, but it will pretend to be real API for certain calls. That's the right approach, huh? No, but yeah. But that's right. Of course, I'm re-implementing mocking, but I'm doing it outside of the test method. So this is done outside of the test method, and
just test class that will create ready-to-use mocks, and you can share this ready-to-use mocks with.
Yes, okay, that's what I'm saying. But don't call it mocks in this case, because you will.
The only reason is just don't call it mocks.
Don't use mocking frameworks. That's my point. Because with mocking frameworks, you will make it the wrong way. If you do it like you said, create some class which design everything for you, that's perfect because there will be no mocking frameworks. The code will look maintainable. It will be easy to understand. With the mocking framework, you will just design something which you need for this particular unit test.
You can override everything like mocks. You can define each behavior for whole API.
You can or you have to? You can, but you're not going to do that. You will just define something.
Yeah, but you can.
Well, but nobody does that. All we do is just we create a mock and then we create a book and then see, okay, the book calls something, it breaks, we just re-implement, we mock one call and we are happy and we call this test like it passes. But then in the future something changes and the test breaks. But when you create a fake object which is suitable for all tests, you will design it properly. You would make sure that it responds to all calls, it behaves like a real database server, it works correctly. And it's going to be an object by itself. It's going to be a real class which is designed properly, which you're going to pay attention for, and then all the tests will use that stuff. So that's the difference. Of course, it's all mocking. We can call it. It's the same name, but it's differently designed. So when you design it for the purpose of one particular test method, it's wrong because you will make it specifically suitable for one situation, and when the situation changes, it will break. Thank you very much. If you have more questions, later.